Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video, we're going to be focusing on elements, ions, and isotopes. Now, this probably, for some of you, is just a review from, middle school or pre-AP chemistry, and you might find it simple. For others, it might not, so let's just go ahead and talk about it. It's not that very hard, but it's going to take some practice. Okay, so we have our I talked about Bohr's atom in the previous video. We talked about the hydrogen atom and how everything was related together. Now let's really focus on the dumbed down version of the atom. So this is probably the version of the atom that you saw in elementary school and middle school. It's not actually correct, but for now, it's going to explain most of the things that we need to understand. So basically, you have the atom, and it consists of the subatomic particles. Sub means like lower, so you can think of it like the things that make up the atoms, right? So you have protons, they have a positive charge, and the symbol for protons is P plus. You have neutrons, which have a neutral charge, and the symbol for that is N0. And then you have electrons, which have a negative charge, and those have a symbol of E minus. Protons and neutrons are found in the nucleus, so this is the nucleus, the very center. It's a very dense area. And the electrons are found in the electron cloud. So electron cloud is the outside where these electrons are just moving around, okay? Atomic number and atomic mass. So atomic number is the number of protons in the atom, okay? And atomic number is typically referred to as Z. So if you ever see that, it says Z for hydrogen, for example, would just be 1. So if you see that, that's what the big capital Z, we saw that in the previous video, that's what it's talking about. That's just how chemists talk about. It's like their symbol for atomic number. So atomic number is the number of protons in the atom. The atomic mass is the number of protons plus the neutrons. Okay, the number of protons an atom has determines which element that atom is. So it's very critical. Okay, so if you wanted to identify what element an atom is, you have to look at the number of protons. There's no other way of looking at it. Okay, and we're looking at that. So if you look at a periodic table, it tells you the atomic number of each element. So for example, if you look at, it might be kind of hard to see here, but if you look at copper, there's a 29 up there. You can go get your own periodic table and look at that. So this tells you that all atoms which have 29 protons are of the element copper. Another example, carbon has an atomic number of 6. So this means that any atom which has 6 protons is going to be carbon. Okay, so you get the drift. The periodic table tells you which atomic number is associated with which element, and any atom which has that many number of protons is going to be that element. Okay, so let's get some practice here. Let's identify the atomic number, atomic mass, and the element of the atoms below. So I think I said that the red circles were the protons and the green circles were the neutrons, so let's go ahead and get that. Oh, by the way, in reality, the protons and the neutrons are way more mass than the electrons. So the protons and neutrons are significantly bigger than the electrons in an atom. But if I put this into scale, then you wouldn't be able to see the electrons. But make sure you know that protons and neutrons are significantly more massive than the electrons, okay? So here, let's look at this example. So we have 4 protons, if you count correctly, and then we also have 4 neutrons, it looks like. So that means the atomic number is 4. The atomic number is 4. Let me just put Z, because that's what the symbol for atomic number is 4. And then the atomic mass is 8, okay, because we have 4 protons and 4 neutrons, so that's 8. Okay, and then we want to identify what the element is, so we're going to have to look at the periodic table here. And if you look at the periodic table for 4, which is right here, it tells us that if an atom has 4 protons, essentially it has an atomic number of 4. That atom is going to be of the element beryllium. So this atom is beryllium. Okay. Now let's look here. So the atomic number, let's look. So 1, 2, 3, 4, 5, 6, I think. Yeah, so 6. The atomic number is 6. The atomic mass is going to be the number of protons plus the number of neutrons. I think we have 1, 2, 3, 4 neutrons. So 6 plus 4 is 10. So the atomic mass is 10. And then in order to identify the element, we have to look at the atomic number. So the atomic number is 6. So if you go back to the periodic table, I think I already mentioned this. It says here that 6 for an atom which has atomic number of 6, that element is carbon. So this atom here is the element carbon. Okay, pretty simple. Now, isotopes are atoms which have the same number of protons, so essentially they have the same atomic number, but are different in the number of neutrons, so they have different atomic masses. So same atomic number, different atomic masses. Okay, so if you look here, all these atoms here have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. They all have 6 protons, so they all have the same atomic number, but they all have the different number of neutrons. This has 1, 2, 3, 4. This has 1, 2, 3, 4, 5. This has 1, 2, 3, 4, 5, 6 neutrons. Okay, so whenever you see this, these are called isotopes. Okay, so the isotopes of an element are when you have the same number of protons, but you have a different number of neutrons. So essentially, you have different atomic masses. Okay. Now, ions are atoms which are charged. They have a different number of protons and electrons. Okay, so if you looked at all the examples here, you might have not noticed, but the number of protons was equal to the number of neutrons. So whenever you have that, the charge is 0. For example, if you look at this atom here, we have 1, 2, 3, 4, 5, 6 protons, so that's a plus 6 charge. And then you have 1, 2, 3, 4, 5, 6 electrons, so that's a minus 6 charge, so it's electrically neutral. Okay. However, in ions, you don't have the same number of protons and electrons. So in these cases, you're going to have ions. So let's go ahead and look at these ions and see the charge on them. So this atom has 1, 2, 3, 4, 5, 6 protons, and it has 1, 2, 3, 4 electrons. So you have a plus 6 charge for the protons. Remember, protons have a positive charge. If you have 6 of them, there's a plus 6, and then you have 4 electrons. So that's a minus 4 charge, okay? So the overall charge, when you add that up, is going to be plus 2. So you would say that this ion right here has a charge of plus 2. Now, let's look here, we have 1, 2, 3, 4, 5, 6. So we have, again, plus 6 as our charge from the protons, because there's 6 protons. Each proton has a charge of plus 1, so there's plus 6. And these number of electrons, 1, 2, 3, 4, 5, 6, 7. So there's a minus 7 charge from the electrons. You add that together, and then you're going to get a minus 1 charge. So you'd say that this ion would have a minus 1 charge. Okay. So how does this all tie together? How do we represent this? Okay. So whenever you're talking about an atom and you want to talk about the how to represent it, you typically use this format right here. So you have X as the atomic symbol, so that's basically the symbol of the element. You have Y at the top here, that's the atomic mass, again, number of protons, number of neutrons, and then you have Z, which is the atomic number. And then in the top right corner, you indicate the charge. Okay, so for example here, let's look at this this atom here. We have 1, 2, 3, 4, 5, 6. So our atomic number is 6, so let's write that down here. We have 1, 2, 3, 4, 5, 6 neutrons. So 6 plus 6, number of protons plus number of neutrons is 12. So we'd say that our atomic mass is 12. Okay, and then we can get the symbol. We know that if you look at the periodic table, it says here that for 6 it's associated with C or carbon. So essentially, what this is saying is that any atom which has atomic number of 6, essentially 6 protons, is going to be the element carbon. So you can just put a big C right here. And then we have 6 protons, 1, 2, 3, 4, 5, 6, and we have 1, 2, 3, 4, 5, 6, 7 electrons. So plus 6 charge from the protons, minus 7 charge from the electrons. You add that together and we're going to get a total of a minus 1 charge. So we just put that charge here, minus 1. Actually, whenever you're talking about charge, I know this is kind of weird, but whenever you're putting this in the symbol here, just put 1 minus, okay? That's kind of weird. Here, if you wanted to, you can always say +2 -1. But really, whenever you're putting it in the in this type of format, make sure you put the number first before you put the if it's positive or negative. Okay, I know that's kind of weird, but we tend to do that. Also, another weird rule is that whenever the charge is -1, don't put 1 minus, just put minus like this. Okay. And it's real weird chemistry rules, but yeah, just put minus. This is only for -1 and +1. If it was +1, we just put plus. We wouldn't put 1 plus. However, for anything else, let's say if the charge was -3, we'd put 3 minus. Okay, but for 1 and +1 and -1, for those charges, you just put the symbol a minus or a plus sign. You don't put the number. Okay, and I think if we do these 3 examples, you're going to get that. Okay, so let's fill out this chart over here. So we given the isotope and asked the atomic number. So the atomic number here is 6 because that's where the atomic number is located. The mass number is 12. Okay, so that's pretty simple. We know the number of protons is the atomic number, so that's 6. We know that the mass number is the number of protons plus the number of neutrons. So we know that if you have 6 neutrons, then the mass number is going to be 12. The 6 plus 6 is 12, great. And the number of electrons, okay, I forgot to mention this, but if the charge is 0, then you're not going to put a 0 here, you're just going to leave it blank, okay? And since we know that there's 6 protons, there's going to be a positive charge of +6. In order to balance that out, there needs to be a negative charge of -6. If we're going to get a negative charge of -6, there has to be 6 electrons, okay? Now let's look here. We have the atomic number to be 20 and the mass number to be 41. We know that the atomic number is the number of protons, so we can just put that 20 here. The neutrons plus the protons equals the mass number. What number plus 20 equals 41 is 21, so 20 plus 21 equals 41, so we're getting the mass number. And finally, the number of electrons, we know that there's let's say 20 protons, so there's a plus 20 charge. And then we know that, oh, this is kind of difficult, we know that since there's a +2 charge, there needs to be 18 electrons, right? Because if you have a plus 20 charge from the protons and you have a minus 18 charge from the electrons, you're going to get a total overall charge of +2. So there must be 18 electrons. Okay. Now here, it's going to get tricky. We're going to have to write the symbols out. So we have the number of protons and we have the mass number. So let's first, we know that the atomic number is the number of protons, so we can just put a 16 here. Okay, that's great. We know that the mass number is the number of protons plus the number of neutrons. We know that we're given that the mass number is 32 and the number of protons is 16, so the number of neutrons needs to be 16 because 16 plus 16 equals 32. Here, and then we can finally write the notation for the isotope. So we're going to have to write the atomic number at the bottom, so we'd say 16. We'd put the mass number at the top, 32. Our symbol, if you look here in the periodic table, 16 indicates sulfur, so any atom which has an atomic number 16 is going to be sulfur. So we put a S here. And then finally for the charge, we have 16 protons, so that's the overall charge of +16, positive charge, overall positive charge. And then we have 18 electrons, so that's the overall negative charge of -18. If you add that together, we're going to get a charge of -2. So therefore, our charge here, which we indicate here, is going to be 2 minus. Okay, make sure you don't put -2; it's 2 minus. Okay. Okay, let's do these examples over here. Here we're given the number of protons. We know that the number of protons is the atomic number, so you can let's just write 50 here. The mass number is the number of protons plus the number of neutrons, so 50 plus 69 is 119. So let's go ahead and just write the isotope notation. So we're going to have to write, I'm going to write it right here. I'm really losing room. I'm going to write it right here. So we're going to write 50, okay, because that's the atomic number. We got the mass number at the top, 119. If you look at the periodic table, it tells us that the atomic number for, when you have the atomic number of 50, that our element is going to be Sn, which is tin, so we can just go ahead and put Sn here. And then finally for the charge, we have 50 protons, so that's an overall charge of plus 50, overall positive charge of plus 50. And we have 46 electrons, which is a overall negative charge of minus 46. Add them together and we're getting a plus 4 charge, so we can just put 4 plus right here, okay? And finally, let's do our last example. Number of protons, it tells us, is 37, so our atomic number is 37. The mass number is the number of protons plus the number of neutrons, so 37 plus 48 is 85. Okay, and then we can go ahead and write our symbol here. Let's our notation. So put the atomic number at the bottom, 37. Put the mass number at the top, 85. Look at the periodic table. It tells us that for a atom which has 37, let's see, 37 is right here. 37 has an atomic number of 37. The element is going to be rubidium, so we just put Rb here. And then finally for the charge, we have 37 protons and 36 electrons, so plus 37 charge from the protons and a minus 36 charge from the electrons. Add that up, we're getting a plus 1 charge, so we just put plus. Okay, because again, since it's plus 1, we're not going to put the 1 plus, we're just going to put plus. Okay. Important side notes: when a chemist are discussing ions, they typically will not use isotopic notation. So when chemists are talking about ions, let's just say they're saying the calcium 2 plus let's say they're saying the calcium ion, they would not put these numbers here. They just put Ca2 plus. When you go into chemistry more, you're going to see that it's not really necessary to put this these numbers here. This is called like the isotopic notation, but typically when chemists are talking about ions, or elements for that matter, they're not going to really care about these numbers here. But I'm just going to do that just to make sure you understand mass number. So it's only really critical when you're talking about nuclear chemistry, but these two numbers here, when you talk about the atomic number and the mass number, not really important. So whenever chemists are talking about ions and elements, you're just going to put the symbol and the charge, okay? So just if you see that in a chemistry textbook without the two numbers indicating the mass number and the atomic number, don't freak out. That's actually correct. It's actually more common, okay? Yeah. Instead, they'll write just the element symbol and the charge, yes. And also, we talked about this, when the charge is plus 1 or minus 1, just write minus or plus. Okay, and also, if the charge is just 0, then don't put anything, kind of like in this example here, don't put 0, just leave it blank, okay? And that's it for elements, ions, and isotopes. I hope this video helped you review on those old middle school concepts, or if it's new to you, I hope it helped you as well. Elements, ions, and isotopes are as simple as that.